Is that streaming? How do I check? Oh, it's connecting. There we go. Cool. There we go. Mm, okay. So, in some exciting news, I got some Double O version 3. Oh god, of course my camera knocks over immediately. Jesus. uh, no, no, no. Okay. Um, it's moving. I don't like this. I don't like that the camera's moving. Is it still moving? Very professional. Okay, great. I got some new Double O boards. This is version. It says it's 3.0, but in reality, this is like pre-release 3.0. I call it 3.J, and it's got some exciting differences. I'm using a. Actually, let me get the 3D models up instead of showing you the bare PCB. Yeah. So on the top is a render of version 3.0, and on the bottom is version 2.7, the last one. So I've switched from using the ESP32 Pico D4, which is 7 millimeters, to the U4WDH, which is 5 millimeters. We will see if that works, and if I have to switch it back, then I will. But seems promising. This is a lot cheaper and seems roughly as capable for these purposes. Using the CP2102N instead of the 2104 just because it's more available and cheaper, and the 2104 is not recommended for new designs. What I'm really excited about is instead of using this Texas Instruments dual output buck voltage regulator, buck converter that I've had lots of problems with, I've switched to these adorable independent buck regulators that come with the inductor piggybacked on top of the chip itself. I'm looking forward to showing them off on the microscope when I get to that part of the assembly. But first, finish the wine, put it away, and get to paste time. So last time I did this, it took me 3 tries. Let's see if I can beat that. I'm only planning to make 1 board tonight. Or, well, 2, because it's 2 boards per batch. But, hopefully it goes a bit better. This is a new stencil. It has a bit of a warp in it, but let's see if I can manage. And I still don't have a proper squeegee. I'm still using bread bag clips. I don't even know what other countries have these, or if it's just an America thing. But it makes for a decent squeegee. Good flexibility, good control, especially this size. Woo. Missed one aperture altogether. Alright, let's see how that went. Oh, it's stuck. There we go. Do a quick inspection. Huh. The scope output looks dim. All right. That looks fine. Looks fine. A little messy, but fine. I've never really been an adherent of precise paste application. Great. That was fast and easy, and now I can start the assembly. Last time I was making, what, 4 boards at once? 8 boards at once. So that meant, God, fucking, God. So that meant I prepped everything very carefully and like binned the correct number of parts. I haven't done that this time. So I'm going to see how long it takes me to just grab everything from each respective bag, place it, seal the bag back up, put it away, get the next bag. Hopefully that won't take too long. But yeah, starting with the semiconductors, I guess I'll start with the biggest ones, the U4WDH, which I am quite excited about using. Where is my... out there, my wire cutters. I mean flush cutters. Good. Yeah, I have probably done 0.35 millimeter pitch chips in the past. I just don't recall when. I have exactly 5 of the U4WDHs, and now they're out of stock every place, so I hope this works. And if it doesn't, then, well, I only have 5 of them, so it doesn't matter that much anyway. Trying to remember which orientation to put them in. Eventually I'm going to have to get a better microscope, because this one I'm already pushing the limits of what I can visually inspect with it. I hate having to contort my wrist like that. I had an idea for an amazing tweezer invention that would reduce wrist strain when flipping over parts, but that's for another time. That's a different invention. Different stream opportunity. Alright, close enough. So, like I said, I'm using the CP2102N, but this board here is not the same as the board I just showed a 3D render of. This one still uses the 2104 because I didn't realize you need to add a voltage divider on one of the inputs to the 2102N. This board doesn't have such a feature, and so we're stuck with the 2104. And that's not great because I think maybe these got static damage. They're not in their original anti-static bag, and I'm not super confident in their viability. but at least they're easy to rework. Man. Oh, you know what? I think I know why this is. There we go. There we go. Okay. Woohoo! Yay. Trying to line this up better. There we go. Okay. And next, I've got some supervisor circuits, some PMIC supervisors. It doesn't look like it now, but this is 3 pads right here for a teeny tiny voltage supervisor. I'm putting one on this board even though it's going to be less than useless, because the only ones that I could find in stock were 3.2 volt voltage supervisors, which means when the supply voltage, like the LiPo battery, goes under 3.2 volts, these shut off. Like, this pulls down the enable pin and stops the all the power from flowing through the system. But I really need a 3.4 or 3.5 volt one, and they are out of stock, or they come in ridiculously huge packages, which was great when I had it in a form that needed to be hand soldered on the back of the board, but you know, ideally I would have no parts on the back of the board. Yeah, look how tiny this thing is. Look how tiny. Alright. And one more. It doesn't look like it's lined up the same way. Make sure I got this. Yep, there we go. Ah, so small. Good enough. Oh, I should be stacking these in a better way. Oh well. And I just shoot. Oh, did my camera tip again? It did. Whatever. Let's see what else we got. One sec. Did I just lose my whole stream? I have no idea how this works. Oh no, it's back. Good. Good, good. Video resolution not optimal. Thanks, YouTube. I mean, look at this crummy microscope output. Of course it's not optimal. Alright. Here we go. These exciting step-down modules, the buck converters. Ooh. So, with a regular buck converter, the largest space by area is usually the power inductor that you have to put on the output of a switching regulator like these. And so, TI decided with some of their chips that they were going to just put the inductor on the chip itself, like piggybacking on top, which is great. I think more chips should permit that. Like, imagine if you could put your decoupling capacitors on the package itself instead of right next to the package. That would create more space, which on a tiny board like this, I guess I'm one of the only people who, well no, that can't be right. there's definitely more people who care about tiny, tiny space applications, space constraints, and what have you. Alright, where's the dot? Shoot. Is that the dot there? Is that a silk screen or is that a via? Huh. Yeah, I think that's the silkscreen dot indicating pin 1. Alright, no pressure. Okay, come on. Ugh. Trying again. No pressure. Hey. No, that's not aligned enough. Scary. Okay. It'll line itself up. Murata has an even more adorable IC for this approach, where the entire package is an inductor and looks like a turtle shell. It's very cute and I love it, but they only come in fixed packages and I need one fixed and one adjustable for these. And so I could have gone with the Murata for the fixed and the Texas Instruments for the adjustable. Maybe that would have made sense because the fixed and adjustable ones look identical, but it seemed like one of those things where I could be convinced either way. Maybe it's better to have two manufacturers, maybe it's better to have one. Anyway, so that was the 3.3 volt one. Now we are trying to unroll this Taquito that has the adjustable ICs. Like with the U4WDH, I only bought 5 of each. This is my test, see how well they go, but like, I'm optimistic. I had a really hard time getting the dual output chip that I was using before to work well, to route it well with these 2 layers with such a tiny space available. It's a lot easier just having 2 separate modules. And these come in 1 amp, 2 amp, and 3 amp varieties. This is just the 1 amp rated converter, but as far as I can tell, they're all the same basic size and appearance. I don't know how they differentiate. Okay. Which board am I looking at? Oops, starting to shake. Really starting to shake. Man. Quit that. Quit that shake. Good enough. Alright, which other chips do I need to put on? The pre-biased NPN transistors, which I only became aware of recently, or became aware that I needed. I'm still not entirely clear if I do need them or not. I mean, they're always a good idea to have, but I did not have them on any of my previous boards, and it was only the last batch of version 2.7s that seemed to fail without them, so I had to rework and add a couple bias resistors. And then I just went out and bought these pre-biased transistors, and hopefully that'll solve all of the programming issues I had with the last batch. Last time I did this, I put on some music and it completely it played over the microphone, which meant I couldn't live stream anymore because of copyright things. That was interesting. I think I've fixed my settings now, but I'm not listening to any music yet. But I don't know, I could be overwhelming you with Devo and British Sea Power right now. Alright. These dual NPN packages always gave me, or not always, but you know, the first time I saw a dual NPN package like this, I was very confused because I couldn't find the pin or any indicator mark that indicating pin 1. This one seems to have marked pin 1 for us, but sometimes they just don't. There are no markings showing you which orientation to put it in. And of course that's because these are radially symmetric. Oop, and I just lost it. Let's get it back. Yeah. Come on. Don't fly away. I've got two jumpers here. You can see this one does not have paste on it. This one does. Kind of just a reminder to myself that this one is supposed to be closed, shorted with solder all the time, and this one should only be jumpered when you want to reset the settings on the EEPROM of the chip. Really exciting, I know. Come on. Exciting. Okay. Let's try and get a little faster. Bag away. Oh gosh, I have to put in the battery charging regulator, the MCP73, whatever it is. And I don't have that here. One moment, please. This is now the largest part on the board in terms of pitch. I mean, this 5-pin IC is practically as large as the 24-pin USB UART converter. It's also definitely the tallest part on the board. Even those buck regulators with the buck converters with the inductors piggybacked on top of them, they're shorter than these. But the super tiny, like LGA version of this ends up taking up about the same size real estate on a board, so I didn't really see the point. Eventually I should learn to just use a different, better battery management IC, but you know, this one is accessible, probably good for an open source hardware design, available from many suppliers, pretty understandable, pretty hackable. Woo. Alright. Is that all the ICs? Yes, and then the PMOSFETs. I guess I'm doing all the semiconductors first and then all the passives. Just that's how I stacked them up in my bag, in my stack of stuff. Oh, I need 4P MOSFETs. So up here, this one is coupled with a Schottky diode that needs to be rated for however much power is going to both of to basically every part in the system. The battery charging, the Wi-Fi module, the output of the motor. So it needs to be rated for, I would say, at least 1 amp, preferably more. And the only ones I have available are 200 milliamps, and I don't know how that happened. And I checked in my stockpile, the Schottky diodes, not the PMOSs. I checked in my stockpile, and the only ones I seem to have are either 200 milliamp rated or 100 milliamp rated. And I think this means I have been using grossly underpowered Schottky diodes on all of these boards since I started making them. I have the correct diodes, power Schottky diodes on the way, but for now I'm just going to assemble these with the 200 milliamp rated ones, and I guess just not drive the biggest vibrator I have with them. Yeah, here are my 200 milliamp ones. I'm just going to quickly check Twitter. Don't care. Okay, yeah. Seems like the stream worked. That's good. So here we have our 0402 size diodes. I had a very hard time finding diodes that were the right size, the right size and the right power rating. They're all either too small or too big. I couldn't find any or rated for the wrong current. I didn't find any that seemed to meet all of those criteria. Oh wait, no. I only took out 2. I need 4. But these, they're basically 0402 components, just with slightly inset pads and polarized. That work? Yeah. Shaking too much. Not great. Yeah, on this board I did place them on standard 0402 packages, I believe. Like the same one you would use for a resistor or a capacitor in the 0402 size. But, it's built differently than a passive component in the same package, so the pads should be closer together. And that is something I have already adjusted. Oh wait, no, not that. That one. Right, yeah. Man, I guess I'm not shaking that much, but I am shaking a little bit. Hand tremors. I don't know if that means I should have more wine or less. Evidently just currently the wrong amount of wine. Now I'm annoyed with myself because I opened this reel from this strip of tape from both ends. I've taken components from both sides of that diode reel. Alright, let's do these. I think this will be the end of the semiconductors on the board, except for the diode, I mean the LED. Other than the LED, we'll just have passives to place after this, I believe. Oh yeah, one other fun thing that's going to happen is the point where I need to place a 120 picofarad capacitor. I do not have a 120 picofarad capacitor. I do have about 1,033 picofarad capacitors. So we're going to try doing a stack up. Make a very, very tall 0402 capacitor. Alright, and time for passives. I got my printout, my notes to reference, but also I just have stacked these roughly in an order that I think makes sense. But, you know, that's why I'm doing this test run, to see if it actually makes sense. Starting on this side, the antenna side. If anyone has RF advice, other than use 4 layers, because I can't, this is a 0.6 millimeter PCB, and no one seems to want to make a 4 layer 0.6 millimeter PCB. Yeah, if anyone has any advice on the RF, right now my best idea is use a bigger antenna, although I've had pretty good success with the existing antenna that's on here. It's like a 3216 pack or 3212 package or something like that. Not bad. And I don't remember why this inductor specifically is 0603. It's the only 0603 component on this board, and I don't remember why I did that. It must have something to do with the 50 ohm impedance. I genuinely no idea. None whatsoever. Yeah, but yeah, here are the antennas. Went on one of those DigiKey deep dives, see all of the different 2.4 gigahertz antenna options. It's the difference in price is, I don't know how much of it is like chip shortage related and how much is just different manufacturing techniques, but wow, like I do not want to pay $20 per antenna for these boards, but if I wanted to, I could. That is a thing that is available to me, and I could not tell the difference in quality. There we go, chip antennas placed. Let's see, now it's all washed out. Can I adjust the brightness a little bit? Nah. And then little 1.5 picofarad caps. Let me see if I can... Oh yeah, okay, that helps my visibility, good. I'm learning how to stream the things I need, like a backlight. I guess I could stack up many of these 1.5 picofarad caps to make my 120 picofarad cap. That could be fun. These are just passives. I don't really need to place them that carefully. Right next to it is R13, one of the many 68 kilo ohm resistors. I bought a strip of 100 of them when I started assembling double O's, and now I'm down to the last 4, which is kind of exciting. I've got another strip, of course, now, but kind of neat to finish off a strip of 100 of a component. That doesn't happen to me that often. Just for the last 5 years or so, it's generally been that I move away before I have time, and I don't want to take the strip with me, so I just give it away. I mean, it's only about 3 cents worth of parts that I'm giving away, so it's more like someone else is taking my trash on my behalf. While I'm at it, I may as well place these other 2 that I have. Come on. Alright, just lose all of the paste on there. That's fine. These are passives. They don't matter that much. They can be reworked. Also, you can see here the gold pads. This is my first time getting hard gold fingers on a board, and I was quite surprised to see this retraction. Like on previous boards that did not get the hard gold treatment, but regular ENIG gold, the pads go much closer to the edge. And, you know, I thought maybe that was because they beveled the edge, like supposedly you're supposed to do with gold fingers, but I've looked at these from the side, and there is no bevel here. They did not mill this or bevel it at all. So maybe they just trimmed my pads to make it look like they had beveled this. I don't know, because like there are other pads that are closer to the edge than these ones. I don't know why these ones on every single board that I received are so retracted from the edge. Alright, got my other 68Ks. Guess I'll put those on later. Let's hear. More inductors. Don't need inductors, because I've got these buck converters with the inductors provided. Where are my 4.7K? Alright, 4.7 microfarad. Put on some caps. So right here, on this reset circuit, I had 0.1 microfarad caps. I have now increased them to 4.7. I could get away with 1 or 2.2 probably, but 0.1 was definitely too small. And yeah, who was I talking to about this? I don't remember now who I was talking to about this, but someone was saying that 4.7 was too large, got to use 0.1, and that goes against the manufacturer's own recommendations, which are to use at least 1 microfarad, but I guess they've changed it. This is all data taken from the Espressif wiki, so it is rather fluid as far as a data sheet or a source of information goes. And apparently it used to advise 0.1 microfarad, and now it advises nothing less than 1 microfarad. Don't know what to make of that. Should I place any more of these right now? Nah. Okay, I need to place whatever's next is going to be R8, a 1K resistor, but I'm going to use a 3.3K resistor because I don't like having a 1K, a 2K, and a 3.3K on this board. I'm going to see if I can't get away with all of them being 3.3K. Riveting stuff. You know, now that I think about it, this might be more interesting if you could see the schematic as I'm doing this. That would be fun. Show maybe a render of the no, you don't need a render of the PCB because you've got the live view of the PCB, but it could be fun to show this next to the schematic and annotate it as I'm going. That would be cool. I should try that. So then R2 and R4 also need to be 3.3K. That's you. Yep. Ugh, God. Again, the whole wrist contortion thing. I have a couple harebrained ideas on how to improve. Wow, this camera is very skewed. It'll be fine. I'm hoping I get far enough in this tonight to actually program these, but who knows. Alright, next is the R2, which is, no, R4. Where's R4 on this board? Oh, it is here. My current limiting resistor for the LED. 2 kilo ohm was too bright, so now we're trying 3.3. It's not. Come on. Good. Yeah, it'll be nice to reduce my part count if I can. Instead of having 3 different resistor values there, make them all 3.3. Basically, all of the resistor values that I could get away with whatever. I made 68 kilo ohm on this board. I'm sure I've told this before, but that's because 68 was close to 69. It just felt like the right thing to do on this board. Although 420 was right there. Like 420 is an actual easy to use value. In fact, 420K is on my new board, not this one, the new one. Alright, I need a bunch of 4.7 microfarad caps. I already put one of each on. So C1, C2, C4, and C7. You can't see what I'm talking about when I give these cap names, so that's another thing I should consider how to do on these streams, or just in a recording in general when they are more tightly edited. Definitely this is a format that is better for being tightly edited and not streamed. Well, maybe not. Probably depends on the charisma of the streamer. I don't think highly of my own. Okay. Alright, that was... yeah, I should just be checking things off. Yes. Oh, I am excited to show off my brilliant innovation for the spring terminals. That'll be fun. Okay, so what do we got? Let's check off the parts as we go. C3, Q1, antenna, L1, C8, R13, U4, R7, R8, U2, R2, U1, R4, yes, C2, Q3, D3, U5, U3, D2, Q2. Is that right? What else am I? U6 and U3, yep. What else did I put on here? Yeah. That looks about complete for now, which means back to back to these 4.7 caps, because that's what I have out. Yeah, I guess I'll place them here. So remaining steps after assembling the passives: melt the board, visually inspect it, and then do the stack of capacitors in parallel to get my necessary 120 picofarads. Oop. Then programming. Never programmed a U4 WDH, so I may have I may not be able to do that tonight, actually, now that I think about it. It's probably not as easy as tweaking the Arduino IDE settings that worked for the Pico D4. And I really don't want to brick these because I only have 5 of them, so yeah, I won't program them tonight. Okay, C1, C2, C3. Did I place C4? I didn't number these very well. There's no rhyme or reason to them. Where is C4? There is a C4 on this board, right? Right? Oh yeah, there it is. Underneath U5. Okay, so I need to place C4 and C7. Oh, they're right next to each other. Good. They are right here. These two under the voltage supervisor. Don't store your passive component. Don't store any of your small components in plastic bags. I'm only doing it because I had a bad idea. I thought I was going to be brilliant and store these in boxes. Those Wentai parts storage boxes. And then I learned that they're not sealed that well, and 0402 components leak out of them pretty readily, like with no trouble at all. They just flow right through. And so I'd already gotten rid of the tape at that point. You know, you can't really put them back into the bandoliers. So plastic bags were my only option at the point. And they're You know, not anti-static, not special in any way. Alright, that's the 4.7s taken care of. Now the 10s. So C5 and C9, these are the output filter caps for these buck converters. They're supposed to be 22 microfarad per the data sheet, but my first instinct was, oh, I'll just use 210 in parallel, and then turned into just 110 microfarad at each, because why not? In the spirit of experimentation. Where's C9? Where is C9? Huh? What? Okay, In retrospect, I seem to have placed these in very bad locations. Or one of them I did. This one, C5, for the 3.3 volt buck converter, is in a very good place. So where did I put C9, the filter, the decoupling cap for the output of the adjustable voltage regulator? Did I put it here? No. Did I put it here? No. I put it up here, which seems dumb. Why did I do that? And did I already fix it in my current board? Because this one, recall, is a pre-release, pre-alpha, alpha. So yeah, in addition to being undersized for the datasheet specifications, it's also too far away, and I won't really get to properly test it on this board because the Schottky diode will probably burn up before I even get to any load that really stresses these caps. So that'll be a fun surprise to tweak on the next iteration. Yeah, those got knocked around, but it's fine. Alright. Couple more parts. Oh, wait, just one? No, that can't be right. No, I've got lots of 68Ks left to place, and the 330 and the 300. Yeah, that's what's going on. I have lots of resistors left to place. Okay, C5, C9, done. C6, saving for the end. Actually, no, I can just put one in now. In my notes, I wrote down that C6 is 4 33 picofarad caps in a trench coat. But let's see, can I... Yeah, I bet I can do this. In fact, I can just swap the location of these two. Right? C6 and R9, I'll just swap their positions so that I can stack things on top of this one easier. Clearly, I've not learned my lesson on paying attention to careful routing around power management ICs, even though I had such a hard time using the last one because of shitty routing. Alright, keep those for later. And start placing some resistors. R9, incidentally, is a 330. In honesty, I don't know if the 330 and 300 kilo ohm values are right anymore. They were right for the last buck converter, the Texas Instruments one that doesn't have a built-in inductor. And so I'm just guessing blindly how the what the right values are going to be for this one. The way I am adjusting the output on the adjustable the adjustable regulator is not by changing the values of the resistors themselves, but by having, instead of just having a simple voltage divider, I've also got a pin connected to the analog output from the ESP32. So that is providing a secondary current source that kind of messes with the feedback loop of the regulator, and depending on the number of microamps that the feedback pin requires, you have to adjust your sequence of modified resistor dividers. R10. Oh yeah. This one just goes right here. So the trouble with this board is it doesn't really give me room to easily experiment and try different values. I'm kind of stuck using 330 and 300 for now. I can rework them later, but it's fussy. I guess I could bond some wires running off of here to some potentiometers. I should do that. I should do that. What's left? What do we have left? Oh yeah, the blue LEDs and 68K resistors. And 330, I just placed those. Right, yes. R9, R10, those are placed. R12. Wait a minute. Oh no, oh no. Okay. So, this one. Great, great. Good catch. The ones that I just placed, the last ones, I need to hit undo. These need to go in a different spot. They need to go, here. Yeah. I guess that's an easier, more charitable position for reworking testing. Definitely was not what I had in mind. Oh, god damn it. Okay, and then on these boards, let's see. Do I only have 68Ks left to place? I think I do. R10, R11, 1, 3, 6, 14, and the blue LED. Yep. Just do the blue LED now. Where's my mirror? Where's my vanity mirror? Say hello to the underside of the microscope, the USB microscope. Alright, so we've got the surface of a mirror. And oh shoot, I'm gonna have to figure out the manual focus on these, aren't I? Wait. Where is... Oh. Oh, okay. So, I need them... Yes, this is the correct orientation. Good. Oh, come on. Alright. I'm pretty proud of myself. I cannot remember the last time I put one of these 0402 LEDs in the wrong way round. Come on, get off. Get off. I need like an alcohol bath or something to dip the tips of my tweezers in. Alright, where are we? Yeah, okay, pointing the right way. Much better. Much easier than the last one. Alright, alright. So I think the next ones are all just 68Ks. The kind of don't care value resistors. How many do I need? Don't remember. Alright, put this where the 300s had been. And then one up here. Yes. Yeah. Good. Is this one R11? Yes, another 68K here. I need to figure out how to quickly and discreetly destickify these tweezer tips. I'm sure someone's investigated and explained in a concise format how tweezer tips get sticky and how to destickify them. I just gotta look it up. Alright. This one here. Ugh. Man. Phooey. Indeed, phooey. I mean, they're good enough. If they tombstone, they tombstone. But I don't think they will. Wait a minute, are these really both? Oh yeah, these are, both of these are 68K. I think in my new version I increased the value somewhat because this is the battery voltage monitor. Need a voltage divider there. And 68K, I don't know, it's a little high. I mean, a little low. It draws a relatively high amount of current. I could get away with like 470K here. Close enough. Ooh, it's almost time to start the preheating of the hot plate. I mean, start the heating. Oh, god damn it. Do I just like have to give this a dip in alcohol? Will that make it less sticky? Tweezer tips. Is it because they have a little paste residue on them? These seem like things I should know the answer to by now. But I am excited to learn them and possibly share with other people who don't know. Why do the tweezer tips get sticky, and how to mitigate that? Good enough. Okay, I believe that is every component. They look fine. All right. Oh, no, that's not true. There is one more component, and it is not on this PCB. It's on the cathode. Anode? Anode. It's on the negative terminal of the battery. Which I've been struggling with design-wise. As you may have seen, surely I have a reference one somewhere around here, yeah. So, the Wi-Fi battery board has a red PCB on one side and a black PCB on the other side that the smaller LiPo sticks into. And I have had to take these little spring terminals from DigiKey and put one on each side because otherwise it's too short. And I just had the hardest time finding like pre-made, easy to get springs that seemed reasonable for a like open source hardware project. I didn't want to have to order custom springs. Oh, that's interesting. This one looks like it didn't mill. Ah, shoot, I shouldn't should get this out of the way. This one looks like it may just not have milled. Is that powder? Oh, it's just powder. It's all caked in there and it comes out. What do I do now with this powder? Shoot. What is this? Okay, I know the running joke is that I keep accidentally eating components, but I'm not going to eat this. This is weird. Oh, it's probably just like the equivalent of sawdust from all the fiberglass on these PCBs. So yeah, that is great. It is aerosol glass. So yeah, now instead of having a spring contact, I have this rectangular pad onto which I am putting an EMI shield. Why an EMI shield? Because the EMI shield is a spring. It's just like the perfect size little springy tab. And so I'm going to test it out. Put a couple of these down with some paste, solder them on. I mean, I guess I could solder them on by hand, but I have a bunch of scrap paste already squirted out. Can't get it back in the tube. I should not be doing this with my tweezers. Why didn't I do this with the tweezers? Dang it. I have regrets. Okay. Get the paste off of the tweezers. Off of the tweezers. Trying to figure out which Sparks song I have stuck in my head right now. I think it's from Big Beat. Big Surprise. Is that one from Big Beat? I don't know. Who else knows the Sparks discography? Yeah, no, it's probably Big Surprise from Big Beat. Like, that's the opening track, I think. I don't know. No one's watching the stream, and definitely no one who listens to Sparks is watching this stream. But if you do listen to Sparks, I want to talk to someone about that documentary, the Edgar Wright documentary. I think Edgar Wright is a great filmmaker. I think this was his first documentary, and it shows. I think the first 15 minutes of this documentary, I thought I was going to die. Like, it was not good. But, you know, it calmed down and just became a normal movie after that. Alrighty. And one more for good measure. Just so I have 3 to play with. And I'm not going to use the tweezers, so I need to slap them down with something else. I guess the X-Acto knife. Burp. Yeah, part of this is an experiment to see what's the right amount of paste. Although I think in all 3 cases here, I have gone with the amount that is way too much. Well, we'll see. And then I have to clean the stencil. I'm still pretty happy with my life hack, my technique for cleaning my last stencil, but that's hopefully not something I have to do with this one. Alright. I should have been doing that while heating up the plate. Something else to think about. Okay, so now I take these, gently put them in the corners here. And we're going to take my very dangerous hot plate and I guess put it over the fiberglass powder. Alright, dangerous hot plate is now on the desk. Camera stand. Eventually I will figure out a better way to stand the camera. Alright. Alright, I'm still streaming, right? Yeah, okay. Let me just double check everything is still working. Good. Okay. Starting to heat. So yeah, this hot plate is very simple and therefore not the safest thing. It's just got a PTC thermistor in here that is tuned so that it has a steady state of roughly 260 Celsius, 250, 260 Celsius ballpark, and that is just being powered by AC. No transformers, no fuses, nothing. So like it was running off of 220 volts when I was in Germany. Now it's running off of 110 because I'm in the US. Heats a little bit slower, but that's fine. Yeah, just like this could be at Earth potential. This could be hot. It's neither right now because there's insulation, but I don't trust that insulation to last forever. Normally I do this outside. I am not today because of cameras and stuff. That is another thing I'm gonna have to figure out. And I'm just gonna put this one on so we can watch. See how the heat proceeds. I would really like to add a thermistor or a temperature sensor, a thermocouple, and an OLED display so I can see this, but it seems like a waste to build like a $40 custom OLED temperature display for this hot plate that cost me $6. If I were to make modifications to it to improve it, I think I should start with some safety ones instead of a temperature display. Whatever. Starting to flow a little bit, we can see that. That's good, that's exciting. Once again, these are electromagnetic interference shield fingers. That's the category they're in DigiKey is EMI filters. But they seem like spring contacts to me. Alright, let's go. I saw some of that paste moving. I see more paste moving. Ooh, we gotta be at temperature now. Yeah. Come on. Well, I guess I'll start the next one. And the next one. The other two, being closer to the thermistor themselves, will probably actually melt sooner. Ooh. That looks very nice. Those are some very nice fillets. Those are very nice fillets. Put that on the mica plate, lovely fillets. Lovely fillets. These are just hot air solder leveled, so the underside of them is a little warped now, but I don't really care. And now time for the main event. Ooh. Just a little scary. I need my other pair of tweezers too. Whoa, look at that. Whoa, okay. Very cool. Good. I don't want them to stay on the heat too long, just in case it damages the DOWD, DO4WD, whatever the initialism is. Those bridges are easy to fix. These ones, come on. Come on. Ooh, I got one tombstone, I see. That's exciting. And all of them? That looks pretty good. Gentle, gentle. I don't have space on the mica. Gentle. Okay. So that should be it for the hot plate. And not even once did my USB microscope fall onto the hot plate this time. That's a first. That is actually a first. Okay. Next we'll do more visual inspection. Hopefully we don't need to turn the hot plate back on. We'll very carefully move it aside. Scary, 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 scary. Scary. Okay. Yeah, that's another thing I need to figure out a better system for. Now, visual inspection time. Lots of shorts. That is fine. Those can be fixed pretty easily. Too shiny. How do I make this less shiny? Okay. Some shorted pins, easy to fix. The resistor looks fine. Have to remember to bridge these with more solder. These all look like they got way too much paste on them, except for this one, which doesn't need more paste on it, but man, these are all just pretty fat. Good. Good. I am delighted with how the the buck regulators look. I think that's a little solder ball that I can, yep, scrape away. Not that it's necessary. Good. I'm very happy with how those look. Alright, next. Good, good, good. Wait, is this the board I already looked at? I think it is. Unless they both have that, no, no paste on that one pad. Yeah, I think this is the one I already looked at. Okay, moving on. Good. I guess I should add more solder to both ends of the antenna, just for its sake. I cannot tell. Oh, actually no, these look like they have very good fillets. Just hard to make it out on the microscope because it's not a great microscope. Yeah, okay. So this all looks like pretty easy cleanup. Hopefully there are no shorts under here. I have no idea. Oh, yeah, those look shorted. So I'll clean those up too. Great. Okay. Let's do this. And the way we do this is with our flux pen and our TS80P. Ooh, I'm excited. Test these out. Okay, first, let's get this here. Much better. Anything else need rework on this side? I don't think so. I feel like I should have applied flux. I think I'm taking away more than I need to on these. Yeah, especially that first one. Now there's barely anything on it. Oop. Yeah. Ooh, shoot, that was bad. That is not... Should not have done that at all. Flux. And some over here, just 'cause. Ugh, that does not look good. Come on. That's so bizarre. Okay. I need to look into that. With better magnification. Good. I won't mess with those too much. Now these ones, which are 0.35 millimeter pitch, God, I cannot tell what I'm doing. This fucking microscope. Like, am I making things worse? Jeez. Those two pads that are shorted are supposed to be shorted. none of these pads are supposed to be shorted. And now several of them are shorted. Oh, it's just because there's no solder mask between them. That's what that brown is. I was so afraid I was scraping up the copper somehow. There we go. Right? No. Ugh. This is weird. Yeah, no, this looks like copper lifting off. What the fuck? Okay, maybe this is copper lifting off. I'll have to investigate with a better camera. I do not like this. Oh my god. Stressful. This is in marked contrast. Oh, this one's that one worked great. Why didn't the other ones work that great? Yeah, just gotta stop and investigate when I have better magnification. Bad, bad, bad. Alright, anyway. I guess I'm not gonna plug these in tonight. Yeah, it really looks like I'm like scraping up the copper. Terrifying. I guess I should make sure that these are lined up and not like, you know, one tab off or what have you. Oh, hi, Roboto. It looks like there's no solder mask to be dragged. Like, I don't know. This is 0.35 millimeter pitch, and this technique has always served me well with 0.5 millimeter pitch. I cannot see where the copper is with this terrible microscope. So I'm gonna have to switch to my like Joomla's loop, which isn't connected to a video feed. And I'll get back to you with that information. But yeah, I don't think I'm going to be plugging these in tonight. But I'm very happy with everything else. This is good to know. This is my first time using this chip, the U4WDH. Is this too wide to be bridged? I might just have to put down some wire there. Thank you for the good luck. Thank you for dropping in to say hi. Woo! I'm very excited to show off all of the new changes that I have prepared for this version 3.0. But, you know, this is just my pre-release candidate. Yeah, come on. There we go. Perfect. All right. Yeah, so I guess just sign off for now, and gotta keep the paste off of that. Okay, just sign off for now and switch to non-video. Thank you.